So friends, we are at calculation of second line of Balmer series. Okay, this we can do that. Equal to 13.6 into 1 square into 1 square minus 1 upon 4 square. So it is your answer. That is how. Let us see how I have done it. Just apply formula 1 upon lambda equal to 7.6 into z square into 1 minus 1 into 1 upon inverse square minus 1 minus 2 square. Okay, and we have done this calculation. As it is second line Balmer series, we know that it is transaction from mode 4 to 2. Okay, so we have done the theory recap. So we will do advanced level questions from Narendra Awasthi. First, we will do on Schrodinger's wave equation question. It is also based on quantum mechanical model of atom. Okay. There is a wave function psi of 3s orbital, which is 1 upon 9 root 3 into 1 upon a naught raised to 3 by 2 into 6 minus 6 sigma plus sigma square into e raised to minus sigma by 2. Okay, where sigma equal to 2r z upon 3 a naught. Okay, so we have to calculate maximum radial distance of node from yes. So this type of question has come in JE advance 2008 to 9. So let's solve this question in 1 minute. So start. We have asked maximum distance from node from nucleus what is really known is that where probability of finding electron is 0. As also we know that psi is a function of probability, so we have to just equal to this expression to 0, that we will get that 6 minus 6 sigma plus sigma square equal to 0. Because this term are constant, so they will not in 0, so we can directly send them to the RHS. So this is our expression. We will get sigma from this, and then we will solve sigma equal to 2RZ upon 3n. So we will get two values of sigma, from where we will reject one and one will be accepted, and that we will equate with this expression. Okay. We can solve easily this expression. 6% this one, 6 minus 25.2, that is 2, 3% minus 2, 3. Okay. They have mentioned that we have to find maximum distance. So we will take only positive sign for maximum distance. Okay. So we got sigma equal to 3 plus root 3. We got sigma equal to 3 plus root 3. Okay. So moving onwards, sigma equal to 2RZ upon 3NF. So we have to calculate this R. Okay. Then what we will do? Sigma, value of sigma is 3 plus root 3. This will be equal to RZ upon 3NF. Just do this. 3 into 3 plus root 3. 3 plus root 3 upon 2 into Z equal to R, and that's the real answer. The key concept was that psi is a function of probability. At the radian at a node, the psi is equal to 0, means probability of finding electron is 0. Okay. So that was our advanced level question that consists of Schrödinger's wave equation as well as quantum mechanical model of atom. Moving onwards, so we will do an important question. It is actually a multi-concept question. Okay. Okay. The radiation corresponding to second line of Balmer series of Ni2 plus In. Okay. Which knockouts electron from first excited state of H plus atom. So what will be the kinetic energy of electron. So it is important question, as it is OSC concept question. We will find two concepts in this. So I am giving you 2 to 3 minutes to solve. Okay. Let's solve the question. Pausing video. Let us start. While solving advanced question, you should know that what kind of concepts are there in question. So in this question, there were two concepts, which are first the knowledge of spectrum, also second photoelectric effect. It is important concept, photoelectric effect. Okay, so we start. It is said that second line of Balmer series with allied to the sign, which knocked out electron from first excited state from H plus ion. Okay. At the instant you have that knocked out, you should get to know that it is of kinetic energy question from photoelectric effect. Okay, it is a case of photoelectric effect. So if you got any clue, you can solve by pausing video. I am continuing. The second line of Balmer series is 4 to 2 transaction. So it's its energy will be 13.6 into Z square 1 by n1 square minus n2 square, and it will become as 9 into 3 by 16. So it will become 13.6 into 27 by 16. It is your EP1. You can see EP1 it is. Okay, move forward. It is your EP1. As you can say EP2, first excited state of H plus ion means transition, you can say from infinity to 2. It will be 13.6 into 1 square upon 1 minus 1 upon 2 square minus 1 upon infinity square. As we know that this is equal to 0. We study it is in limits of maths. It is approximately equal to 0, not actually equal to 0, but in chemistry we do approximation, so it is equal to 0. It is 13.6 into 1 by 4. It is our EP2. For kinetic energy of electrons, we can do kinetic energy to EP1 minus EP2. That is your 13.6 is common, 27 by 16 minus 1 by 4. You can also do that 13.6 into 16 by 16. It is actually 0.85 and it comes approximately 19.55. That is your answer. It is important question by the advance. The point of view of advance. It is a multi-concept question with two concepts. So you have to note it down. It is more important question. So we are now doing a new question. There is more one concept. In administration, important concept. I think you have done, but I will explain it. Distance of closest approach. Actually, it is based on Rutherford's alpha beam scattering experiment. Okay. So what does mean it? Actually, it is important concept with point of view of IIT Advance. It is asked in examination of IIT Advance. So actually, what does mean it? This was a closest approach. When Rutherford was doing this experiment, there is alpha particle source. We can see it is an infinity. We do not know the exact destination of this, so we can say that it is at infinity. Okay. At here, there is nucleus. Okay, there is nucleus. So when alpha particles come here closer to the nucleus, so we know that alpha particles are He2 plus ions, which have 2 plus positive charge, and nucleus also have positive charge. When they come in contact, there is a repulsive force. Due to this, He plus or alpha particles never went inside the nucleus. They just rebounds back in any direction from a distance. Let this be R0, and this R0 is nothing but distance of closest approach. So in IIT JEE, it was asked that find this R0. Okay. So we will use here the concepts of physics, that is work energy theorem. work energy theorem we will use here, okay, which is conservation of conservation of energy, which states that PEI plus KEI equal to PEF plus KEF. It is initial potential and initial kinetic energy. It is final potential and final kinetic energy. So by applying this formula, we will get R naught. So can you predict what will be the R naught? Just think on this and find your R naught. If you got, comment in comment box. Okay. Just think for 2 to 3 minutes. So let us start. What is R naught? It is a concept for IIT JEE Advanced. Okay. As we know that alpha source is at infinity and the nucleus is here at this position. As we know that potential energy formula is 1 upon 4 pi epsilon naught into Q1 Q2 by R. This distance is infinity. So we can do that 1 upon 4 pi epsilon naught into Q1 K. So K is here. No. This is K. Q1 Q2 upon infinity. So this will be 0. So whole term will be equal to 0. So potential energy initial is equal to 0. Okay. So let us consider that alpha particle is traveling with v alpha, means velocity of alpha particle. It is moving with this velocity. Okay. And mass of alpha particle m alpha. Okay. This is moving with v alpha velocity. So we can write Ke of alpha equal to half of m alpha into v alpha square. Okay. That is our Ke I actually. Okay. That is our Ke I. So we have get Ke I. Now let us consider the situation when the alpha particle will be at its closest approach. Let us consider that alpha particle is here. So at momentarily this alpha particle will be at rest here, and potential energy here will be maximum. As it is at rest here, the kinetic energy will be equal to 0. Okay, so we have two conditions. KEI we have what? So we have what? PEF from here. So PEF will be 1.45 epsilon naught into Q1 Q2 by R. R will be here R naught because it is our R naught, na? You got it? We have got R naught PEF, so we can apply COE, then PE I equal to PEF. KEI is this alpha V alpha square equal to 1/4 epsilon naught into Q1 Q2 by R naught. Also you can put values here. You can take Q2 is as alpha and Q1 is charge of ZD, means charge on nucleus. Charge on nucleus is Q1. B alpha is speed of alpha particle, M alpha is mass of alpha particle. Also this is equal to K. You know that value of K. You can put it and calculate R naught, which is distance of approach. Okay. So it was an advanced level concept. If you have a good book, then it will be explained in your book. It is a good book. It will be in a good book. In a good book, it will be. So we have also calculated R naught here. So we will do an advanced level question on this. It is this will be like formula based question for you, because we have calculated the formula also, and if you don't know this formula, it will be very critical to find out that. It is that given that alpha particle have kinetic energy Ke alpha at infinity is equal to pi mega electron volt. Okay, which does not falls but gives is closest approach